Rightio, hey, this is just a quick one. I've had two people now ask about two questions in particular that were in the Walker Maths book last week. So 7C, which was the one about Malachi. He was the one, he was given $1,000 when he was born. He invested it at an interest rate of 1,000 times 1.032 to the power of n. That's the equation that you end up with because it was 32% interest each year, 3.2% interest, sorry. So getting a bit stuck on question 7C. It's where it says Malachi is calculating this thing here. Okay, it says he's calculating that thing there. And the question is, with reference to the investment, explain what Malachi is calculating. Okay, so you're having a wee look at this. Notice it's got a P and a Q in it. In 5C, which was the one about the bacterial population, that question was really similar as well, except it wasn't talking about a P and a Q as such. It just had N, but it's very similar thinking to that, okay? So if you have a wee look at this, the way he's got it here, we're talking about two different time periods, okay? Because those powers, the N, are talking about time periods. So here you've got one of the N's is called P and one of the N's is called Q. So we're talking about two different ones. That's why they've got different letters, okay? And just emphasizing that they're different. One could be after 10 years, one could be after 14 years, who knows? So then if we expand this out, it can demonstrate to you what's going on here. So if you look at this equation, your next step, if you go and just expand out those brackets, okay? So you end up using your power rules. You've got a base, the same base, 1.032, and you've got that base to the power of P, and then you've got that same base to the power of Q, and they're being multiplied by each other. So let's expand out those brackets and do them. It becomes the same base, and then adding those powers together. So you end up with 1.032 to the power of P plus Q. That's our power rule, isn't it? And then expanding out that next term, okay? So that and then that. So minus 1 lot of 1.032 to the power of P. So that just ends up being that guy there. Now, if you expand that out again, you can, by the 1,000 now, because we've got that 1,000 as well that's out the front that's being multiplied by everything. So now expanding everything, multiplying everything by that 1,000, that, oh, sorry, won't do it there, we'll do it up here, 1,000 times that, and then 1,000 times that. And then we're going to end up with this, okay? So we end up with that part there. That's what we get when we do 1,000 times 1.032 to the power of P plus Q. And then we've got the second part here, okay? Notice the negative there, of course, and we've got 1,000 times 1.3 to the power of P. When we've got minusing going on, then remember that can also mean difference, okay? It is the difference between two things. And in this particular situation, it's the difference between this particular time here, which is P, and P, who knows, it could be 2 years or 14 years or whatever, okay, something. And then you've got this other time period, which is called P plus Q. So it's, in other words, you've started at this time and then you've added on some more years, okay? So maybe it might be 2 plus 10 years. Let's say that Q is 10, or it might have been 14 plus 10 years if Q is 10 and P is in fact 14. Okay, so it would be 12 years and 14 years. So what that is, that expression there, is it ends up becoming the difference between P plus Q years and P years. So it might have been, if he wanted to know, okay, what, how much did his investment grow between 5 and 15 years? Okay, and that's just showing it in that beautiful little algebraic expression. Okay, I hope that makes sense. If we then look at 9D, it's really similar. It's that same kind of idea. So 9D was regarding mobile phones, and they depreciate by 35% a year. Depreciate, for those that aren't economists, that means it decreases in value. So this is why we ended up with 0.65. I had a question about that one as well, because it's 1 minus 35% or 0.35. So yep, we ended up with that expression, which was $1,050, his original value, times 0.65 to the power of n for years. And then for question D, once we get down, we do a few things. We get down to D, 1,050 times we're told that he calculates this whole thing here, and then again, with reference to the value of his phone, explain what Andrew is calculating. Okay, and this is the same deal as before. So we've looked at that, and then we can actually expand out these brackets, okay, first of all by the 0.65p, okay, multiply it by the 1, and then multiply it by the 0.65q, and you're going to end up with these two parts, or these two terms, okay, power of p, and then the power of p plus q, expanding out again by the 1050, and you'll end up with these two separate expressions, and this would be the expression for a phone finding out its value after p years, and the second one would be the expression for a phone finding out what its value is after p plus q years. So again, it's the difference between the value of the phone after p years and p plus q years, or to word that a bit better, it's how much it has depreciated in value between p plus q years and p years. Okay, so anyway, I hope that helps for those of you that got stuck on those questions too. And thank you for those 2 of you that did ask the question, because I imagine lots of you probably had the same question.